Begin. The topic for my talk today, which I would like to just share with you my little experience, and also would like to know that how do you place it your this whole perspective in your life, in your research life. The topic is translation of nanotechnology at user scale. To introduce myself, Shruti has kindly given a very nice introduction, a very full of kind words. I would just take you a little back along with my journey while I just finished my PhD in intercellular biomolecular pathways for pest signaling. Uh,
Dr.
and
Kavya,
micro-
sorry to interrupt you. Can you please put your screen on full screen mode?
on
This
full
slide.
screen. Is it okay now?
Uh, it is not full screen. Can you share your screen so that you can?
Yeah, I'll do that. Mm, Let me just share it again. Screen, and I do it entire. Is it okay?
Yeah, now it is visible.
Right.
Okay.
So, microscope. When I was doing PhD, microscope was evolving. There were many higher versions of microscopes which were coming to the researcher's life, and they were, in fact, my interface to the whole different micro world. Living in the macro world where everything was big, giant, and as a budding researcher, obviously I was very attracted towards everything which was macro until I started looking into the microscope and saw there is a whole beautiful world, whole self-sustaining, self-operating world at the micro level. So that was my interface where I disconnected from the major macro and I started getting more and more interested, intrigued, and more absorbed into the micro world. And what I saw and what I studied, what I considered as an efficient engineering, because my exposure to core engineering started after that. And every machine I came across, every technology I came across, henceforth, I had a straight comparison in my mind with the most efficient engineering systems, the cellular engineering and its mechanism. If we look at a cell, even up to the level of DNA, everything is so beautifully packed, everything is so flawlessly packed, and we don't see who's governing it. It is just replicating on its own, and then the copies are made, and then they are carrying the messages which are generations across. And we are still able to find out. In fact, one of the scientists got the Nobel Prize because he extracted the DNA from the cave finger. We are able to extract DNA, the cellular component, from that old of our colleagues, of our human brothers. So, cellular engineering, as per me, is the best engineering device or is the best engineering methodology which ever existed. And what intrigued me most was its mechanism. In code engineering, you call it coding, and in cellular engineering, we call it arrangement. How everything is just arranged, packed, and functioned without somebody controlling it, without somebody making it, and it is still so consistently done. The basic reason which I think I got attracted towards nanotechnology was the quest of knowing the structure, function, and impact of molecules sizing at the nanoscale. Because what we could see in the microscope was something which was of a micro level. Without microscope, it was all macro, then micro. But is there something beyond it? Is there something which is operating in between the spaces? That was the nano space, that was the nano area, which always found a question in my mind that what if we are able to explore little further, little more micro, little more lesser in size to the power 10 to the power of minus 9, and still be able to monitor it, still be able to replicate it, still be able to track and trace it. Now when I say this part, I am saying it in isolation of the most of the research on nanotechnology which was being done in the western part of the world. I was just having these thoughts on my own, and at that time, Google was not there very handy. Information was not as a luxury as it was. It's just so much available right now, but at that time we had to go to libraries, so the connect between the real time technology was fairly less. So the question of, is there something which is operable at that level and is still monitored and can still be monitored, can still be reproduced, can still be controlled, was always there on my mind. And with the first exposure I got to travel outside this country and meet the eminent scientists, read about their work, it just opened so many new doors, which made me enter into the field of nanotechnology. So, if I say it in short, the basic question which attracted me towards nanotechnology was the impact at which the impact at which the nanomaterials can have at the spatial and temporal scale of a living system. And this was perhaps my first debut or triest, because after that I was in deep love with the nanotechnology, so I can take the liberty of calling it a triest also. So triest with nanotechnology. After completing my PhD, I worked for Commonwealth Agriculture and United Nations. I worked for Millennium Development Goal and Sustainable Development Goal promotion, which gave me a huge perception of what a responsible research is, what could be the impact, and what are the gray areas we never look at while we are unleashing a technology without regulations. By the virtue of my placements at United Nations in countries like Horn of Africa, in countries like South America, Asia, I had seen that technology which appears to be a boon initially turns out to be vain, because there are no regulation, there is no hand holding, there is not enough communication. So that technology single-handedly became the bone of contention or the agony point. We just could not retrace from their point onwards. So launching a technology or ideating a technology was one aspect. That was very much an aspect which an engineer thinks about. But what about placing it into the safe hands? So that was my first triest, the field experience. Seeing people benefiting from the technology in one generation and suffering from the same technology in another generation was my first triest with nanotechnology and leveraging translational research to make a sustainable impact and use. If that impact is not sustainable, if that impact is detrimental, if that impact is harmful, then that technology is not even sustainable. That technology is not a technology. It is something which we just unleashed as a part of an experimental test bed. And the difference was our experimental time zone was fairly long. Let us say 35 years, 45 years. That big experiment we planned, and now we are reaping the results of the experiment because we did not foresee what could be the impact. So while I was working with the last mile, uh, over the different continents for 12 years, I realized that accountability should be high because the stakes are very high. One generation adopts an unleashed technology, unregulated technology, and several generations henceforth suffer, and there is no accountability to set. Now, while we are focusing on bigger and luxury things, what we miss out is the important things. What we miss out is our focus on the important things which make us. Like everybody is very careful while they are buying gold, while they are buying a car or a branded clothing, but nobody is careful about where their food is coming. Thrice a day we need food. Once a day or twice a day we need a car. And maybe once a week we need a branded clothing, the same shirt, we may repeat it. But food we need thrice, and there is actually no connect. Where is it coming? Is it safely produced? What impact it has done to my environment? Unless we see pictures like this and they shake us from within, that have we gone a wrong direction? Is the gear of technology being applied in the reverse direction? Because the life of this child is irreversible. This child was born deformed and can never get back to normalcy. Only reason was because the generations who were using pesticides, who were using micromolecules, did not regulate it properly, and eventually it just percolated down to the life of this child, and so on and so forth. There is a district in India, in Kerala, known as Kasargod. That district is known for generations on generation producing deformed children. And who's responsible for it? Perhaps the technology developers. the technology regulators and the technology applicators, the technology users, because we use the technology without realizing the impact of it. And now we are holding a very big signboard saying, I love my family and the environment much more than my lawn. But it means nothing because the damage is already done. If not done directly to my family, done to my species, done to some human being in some part of this world, done to my planet, and done to my environment. So the stake is that high. And if my environment is impacted, my planet is impacted, there is no reason I'll be spared. There is no reason I'll be spared. So this picture, these people, and this infancy, this childhood of these children had made such a huge impact on me during my 12-year journey with United Nations, with Commonwealth, that I reset my focus on using nanotechnology research through a three-pronged approach. First, the micro level, which involves the technology translation and outreach. Then meso level, it takes into consideration the responsible research and technology development. That means if I'm operating at micro level, I would never feel that the last mile is disconnected. The last mile impact, first, the need of the technology, second, the awareness about the technology, third, the impact of the technology, fourth, residue of the technology, and fifth, retracting of the technology will always be on my mind and had been on my mind in every experimental planning which I had been doing. Then at meso level, I had always been a responsible researcher, and I encourage my co-researcher and my fellow students, my fellow researcher and my PhD students, my postdocs, that whenever you are undertaking a research, please do not miss out the last mile. They are the ones who would be acting as your source and your sink both. So make sure the research is inclusive. And then at the macro level, because no matter how efficient the research is, no matter how effective the inclusion is, but if there is no regulation, one day it is going to fall from the cracks. One day the pilferage is going to take a toll on every caution which we are going to make sure. So that policy level arrangement, that policy level awareness, and very specific rules to be laid down, I include all three levels in my research at macro, meso, and micro level. And then realizing that it is a very recent data that more than 10,000 nanotechnology based products are available in the market for commercial use. And when I say that, I just don't mean agricultural products. I mean the cosmetics, which we are using it lavishly, whether it be our bathing soap or gel, whether it be our sunscreen or creams, whether it be our perfumes, everything which we are using, or even the toothpaste, they have those nanocrystal for whitening the teeth. So the nanotechnological products, they are more than 10,000 which are available. Now, does this number ring a bell? I'm sure it does not, because if we talk about a shampoo pouch, so many shampoo pouches are available. So what does this 10,000 number signifies? It signifies that before we have any regulation in any part of the world, 10,000 products are already available in different forms of engineering, whether it is agricultural engineering, food engineering, mechanical engineering, electrical engineering, computer engineering, you name a textile engineering, you name a field, and it is working on nanotechnology, and it is unleashing the product, and from 60 countries. And we all know that southern hemisphere is very typically known as a market, is known as a sink, is known as a source of food, is known as a debris generating area or a debris dumping area, the debris dumping hemisphere. Everything just boils down here. We have all fertile soils, we have all oceans mostly connecting us in the southern hemisphere, and all the nanoparticle actually getting leached down, actually getting precipitated, actually getting settled in the southern hemisphere. So when one country is producing it, we still have a problem because the scale of operation is at the nano scale. Now there are 60 countries and more than 2,500 manufacturers. So this is a point which is to be worried, because if we do not control it now, very soon we'll just be replicating for the monetary sake, for the sake of business, and for the sake of development and growth, and we would be keeping our big eyes shut for the sustainability, for the impact, and these 10,000 is just going to escalate. It is just going to escalate, and the impact is going to be heavier and heavier. So one of the papers produced from my laboratory, by one of my PhD scholars says that all nanoparticles, no matter how good the intent is, when I normally say that no matter how good the intent is, the invisible sentence automatically fills in there, the impact was not so good. So, intent, no matter how good it was, the impact did not prove to be so good, so fruitful, and so secured. And we just worked out. On this paper, we found that gold nanoparticles, titanium dioxide, copper, silver, mixture of copper and iron, copper, iron, nickel, and silver. I mean, these are the major nanoparticles which are used cross industries, cross core engineering themes, and they all have an impact. They all have an impact to soil. And if I just give you, and these are very serious impacts. If you just ask from a life science scientist perspective, these are very, very serious impact. So much serious that if I just give you one small example, there was a big bang, we all know. Hypothetically, nobody was existing then, of course. There was a big bang in the solar system, and two planets, two celestial bodies ejected out of that big bang at the same time, exactly the same time. And those two turned out to be two planets very nearer to each other. One of them is the planet which has life on it, and another, same time they were erupted, same time they existed, very close to each other, very optimal distance from sun. One does not have life at all, but one is still very beautiful. The two planets are Earth and Sun, Earth and Venus. So Venus does not have life and Earth has life. Why? Because Earth has soil, Earth has carbon. Venus does not have carbon. And the presence of soil is the sole reason we have life present on this planet. The presence of soil is the sole reason all the engineering themes are existing. Presence of soil is the sole reason we eat food. So if soil is getting impacted, if soil microbes are getting impacted, if soil biomass is getting impacted, rest everything else is getting impacted. So realizing that, and since you travel more often, you realize it also very often, because very quickly you see it running in front of your eyes. And seeing it more often, I realized that I should condition my mind for something better. So I started conditioning my mind for constantly making a mind map so that it doesn't fall down from my research planning. Doing a SWOT analysis and visualizing how the research impact would look like if it is at the last mile. That means my inclusion of all the stakeholders started at my mind map level itself. And this is what I insist with all the PhD scholars, all the research enthusiasts, all the budding engineers, that whenever you plan a technology, you have to have the last mile in your mind. You just can't do away with the responsibility saying that I am developing a technology for industry. And what is industry doing? Industry is making a product using that technology for the masses. So passively, you are making a technology for masses, and actively, you will be impacted sooner or later. So please do not exclude yourself, and do not make your technology exclusive of yourself. It has to be inclusive from you to the last mile. If you do not want anything negative coming to you, make sure it doesn't go to the last mile and it doesn't go to the planet also. So the rigorous practice of making this mental map, I also found something very interesting, which I would be sharing with you. I found that most of the research we do in the lab are or in the entire lifetime, because some of us are professional researchers. We earn our bread and butter doing research, and it's a day job to do research. So the research is not intended for the last mile. Sometimes it is intended for the funding agency, sometimes it is intended for a promotion sake, and sometimes it is intended for the industry. But last mile, I have found very few people who go up in the laboratory every morning, pick up their tools to work for the last mile. So most of the research we do not intend is not intended for the last mile. And most of the papers we publish in the name of sustainability, in the name of novel research, in the name of breakthrough technology, in the name of game changers, are not even read by the end users, that is growers, that is traders, that is workers, that is customers, that is technology operators. These papers are not even read by those. So no matter how much we highlight the gray areas, that this is what my research is, but these are the gray areas, or these are my failing points, nobody is reading those failing points unless it is a next line researcher. And when it comes to impact, I'm not talking about glory or credit, because success has many fathers, we know. So when it comes to impact, it is difficult to find someone who's accountable. So suppose if we just recall the slide when I had shown the few children who were heavily impacted because of pesticides, if I ask who would be responsible for them, no, not a single person on this planet would be able to name one person, because impacts do not find someone who's accountable, which makes all of us accountable, not none of us accountable. So when all of us are accountable, let us all work in a very responsible way, so that when we are held accountable, we are held accountable with credits and glories, with gratitude, and not with miscredits. And the most important thing which I came to conclude as a part of my journey was, research is brainy, application is emotional. I may do the optimized volume of urea application or nanopesticide application, or nano content of a medicine like a nanopharma application. But when a patient holds that tablet in his hand, or when the relative of the patient holds that tablet in his hand and seeing a dying person in his front, in the front of his eyes, his emotions take over all the regulations, and he would just go on board doing overdoses. A farmer has done this enough. Instead of broadcasting urea for a very limited amount, for a very limited volume, just out of emotion and a temptation that my crop will grow better, he had been broadcasting unleashed volumes. So application of the technology is emotional. My research is brainy. It is all full of pros and cons. Application is emotional. And when it comes to impact, it is generational. And in Hindi, we often say that sadiyon ne lamhon ne khata ki, sadiyon ne saza pai. So the errors which are made in moments, generations follow the brunt. They just bear the brunt of it. So I started looking for the middle ground. Not everything was supposed to be happening as per my wish. And being a very new researcher, a very budding researcher, it was not even possible for me to raise my voice and handhold people to say, just stop whatever you are doing. And let us just reframe this whole thing. Let us reset our frame of operation. No, nobody would have heard me. So I thought I be the best test case for myself, and I reset my systems, because there I assume there would be a whole line after me also, like there is after the stalwarts of researchers. So I thought that there would be a line following me also. So if I reset my system, at least something is set right. So I tried to find a middle ground, where I decided to find a research problem and hypothesize it through backward integration. That means I identified a problem from field. I sought the local solutions. That means problem was existing ever since. How local people were trying to find the reasons. That gave me so many options of what did not work and why. So a big hit and trial was saved, because already certain things were not working. And certain things were not working, but with slight tweaking they were. So instead of applying a whole new technology, just minor modification was helping enough. So I sought local solutions. I took local people on board. Then I identified the critical point of nanotechnology intervention. Since I work on nanotechnology, I obviously looked for the critical point. Uh, like any person who would come and ask me that why researchers do not succeed, or why startups do not succeed, technical startups, I usually say, because you fail to identify the critical point of intervention. Developing a nanoparticle is no big deal. I promise you, it is no big deal. Then thinking of a problem is no big deal. You can find this whole world is full of problems, and everything can be your test bed. But if you're not applying your solution to exact point from where onward it is making a difference, then it is not the critical point you have identified, and it is not the correct stage where technology can meet the problem. And that is where we are all falsifying right now. That is where we are faltering. We are not like doing so much of research but not able to make such a high impact, because the marriage between the critical point and the technology appropriateness is absolutely missing. So I started looking for that, and then I fortified with interdisciplinary translations. Because if I think my research is the golden weapon and it is going to solve all the problem once it is going to be unleashed in the field, that is a very strong misconception I might have. So the best is I would take a couple of expertise more on board, discuss them thoroughly. What could be the impact on your area if I unleash this technology in the field? One example I will give you, and then you might better understand it. Uh, the technology, like the nanotechnology and the nanoparticles, when we decided to release it out in the field, we thought that we were just working for soil conditioning. We thought we were just working for the fertilizer capacity of the soil, avoiding the macroparticles and the macro contaminants. We did not know that we are also contaminating the food chain. We did not know that we are also contaminating the mother's milk. We did not know we are also contaminating the next generation, because it is interfetal transmitted. We did not know that we do not know what is the threshold. We did not know, we just don't know how do we recover it back or how do we trace it back. So when we spoke to several experts who said that chemically it is so small that we cannot even trace it back. We just don't know when it is turning toxic. We just don't know from which point to which point, because though we say it is targeted, but then target gets merged. The nanoparticles most of the time do not even remain like nanoparticles. They get agglomerated, they get clustered, they become little more than or higher sized nanoparticles. They become as good as very small microparticles, and then they have a very different impact. So what would be the impact if this nanoparticle agglomerates or gets collided or gets collaborated with more other particles? Will the chemical properties change? I would only know if I speak to my fellow chemical engineer or my fellow chemist. So I bring in the interdisciplinary expertise before for translating it into a fortified, a safe, a recoverable, a monitorable technology. And I test it under a regulatory framework, so that they know, okay, this is the threshold limit, this is the toxicity level, this is the recovery level, this is the non-interjecting level. That means if it is meant for soil, it should not be entering into water body, or it should not be entering into air beyond this limit. So threshold limits defined. And after these things are sorted, after my technology is given a safety certificate, though virtual enough, but still everybody considering it safety, considering it safe for use, then I launch it in the field. But as scientists, do we really have that much of patience? Because that urge to publish the first report is so high on our minds. That urge to finish the PhD and just jump onto the postdoc era is so high on our mind that we do not even bother to plan our research well. And with missing links, that research becomes best translated as a beautiful PhD thesis somewhere lying in the shelf of our libraries, departmental home library, or with our PhD guide at the most. Although I would say that this is not the perfect roadmap. And I do invite all of you and so many who really feel that unless the technology is taken into a bigger perspective, into a bigger regulatory framework, it should not be let loose. Uh, we can actually develop a very safe roadmap for launching the nanotechnology, because there are more gray areas. The resistance of microbes, we have seen it is coming very quickly. We have seen people dying from very, very basic diseases. And there was a doctor in early this century who had predicted that an era will come very quickly when people will not die of major diseases, because technology will help us to address all of them. But people will die of very common diseases like common cold. And why it would happen? And why it would happen? Because of antimicrobial resistance. And yes, we have reached that stage. I myself have known so many people who have developed antimicrobial resistance, have gone from very healthy in 1 week to almost on the deathbed in 3 weeks time, and just doctors looking helplessly. They said we have treatments for AIDS and COVIDs, but we don't have treatment for antimicrobial resistance. Because if we do not fortify, if we do not lock our technology with a safety lock, it would be too late. It would be too late for us to recover. Now, speaking how nanotechnology or nanoparticles enter into the soil. One, definitely through agricultural production, through biopesticides, through nanopesticides, through nanofertilizers. Second is through industrial processing and use. And third is through waste and residue. Not that if you have made a beautiful sun cream or a beautiful shampoo or a very nice perfume or a very amazing nanotechnology device or an agricultural tool based on nanotechnology, you have done your job. If it goes waste, suppose the shampoo is going waste into the wastewater, and that wastewater stream, eventually the nanoparticles enter into the soil act as source and sink for everything. And we should also remember that whatever goes into the soil comes back into us, because a very good old saying says, dust are we and dust we shall return to. Whatever grows on the soil, we eat it as food. And nanoparticles, I'm going to show you a little further ahead that nanoparticles can cross a blood brain barrier, we know, very small in size, high surface to volume ratio. And then when they enter into our system, we just do not know what are they doing. Right now, are we even happy we are using nanotechnology unleashed, unguarded, unregulated? So the emission, general emission of nanoparticles into the soil, it is through manufacturing, through nano-enabled product manufacturing, for mixing, blending, embedding processes, during machine maintenance, process exhausts, for product application, for wear and tear and waste disposal. And from there, when it just get actually, one of the parts is you use it, and when you use it, after use you refuse it, you refuge it, you throw it as a waste. And during use you are consuming it in your body, because when if something can cross intercellular spaces, if something can cross blood brain barrier, it can definitely cross your skin. So it has already entered into your body, it has already entered into your bloodstream. So during waste, if there is a significant dispersal through air, soil and water, the nanoparticle enter through environmental components. And then there are secondary emissions also. The interaction, how it is just not a one-way route. The interaction of nanoparticle happens through either at the plant interaction stage or at rhizosphere, that is at the soil interaction phase, or nanoparticles above and below ground stage. That means once the nanoparticle has entered in the soil, you can trace it above ground and below ground, both the places. And it would be very difficult for you to find out from where to trace it back. And this particular picture, if you see, this particular example is nanoparticles just interacting with the root exudates, the chemicals which is released by the roots, entering into soil, then entering into the leaves also, imbibed through plants, imbibed through water action by the plants, reaching up to the highest leaf level. The tree can be as big as you imagine, entering into all your so-called exotic, fancy, expensive fruits, which you pay 4 times, 5 times higher to be sure that it is safe for consumption. And it is so filled with nanoparticles. And when you use that when you use that fruit, when you use that grain, when you use that leaf for your favorite salad, you are consuming so much which you did not ask for. You are consuming so much which you did not pay for. You are consuming so much which you did not subscribe for. So there is no running away from it. We see that nanoparticles, which, as I again I'm going to say, that no matter how good the intent was, intent would be, adding it to the soil to avoid harsh chemicals, to avoid the serious micro and macro pesticides, to avoid the hazardous chemicals, no matter how good the intent would be. But the fact remains that it is fast becoming a co-contaminant. It is becoming an emerging contaminant within the toxicity of our food crops. It is having an impact on the nutritional quality. It is having a transgenerational impact, not only in human but also in plants. And the best way to study the impact is plants have a smaller life cycle. If you really want to see what is the impact of a nanoparticle onto the generations, plant a crop. Just do it at a very small area, maybe in your garden, and just spray some nanoparticles. You will be able to trace it until at least 5 generations. And you'll be surprised to know that they are just not destroyed. They are very much there. And yet we do not know how much are they interfering, because they were poured into that area, into that soil, into the original parent plant for some purpose. Are they still doing it, or they are doing something else? And then trophic transfer. Trophic transfer means at different levels of food chain, and we also need to study about it. At what level, starting from soil to human being, there is a whole food chain which exists. At what level we are impacted, or are we even impacted, or there is no escape? And then chronic low dose exposures, and then the effect on rhizosphere, biota, and symbionts. These all are the things where these are like the relevant system, the ecologically relevant systems. They are linked to each other and has been found getting impacted with nanoparticles. Then the few designs. We don't say that technology did not develop itself. The regulation did not, the application did not, the sensitiveness did not, and the awareness did not. But technology did kept on stepping up. Technology did kept on evolving. For one single nanoparticle, we have so many ways, as mentioned on the screen. We have a slow release, quick release, moisture release, heat release, pH release. That means it can be in the stomach or inside the cell. Then ultrasound release and DNA nanocapsule release. So many ways the nanoparticles can be released in the environment or in the target system. So what would happen? At every stage of release, you will have a different impact. You will have a different spatial impact. You will have a different temporal impact. So the health hazards, the issues, which potential health issues, which now doctors have started confirming, they are nanoparticles could be inhaled, swallowed, and absorbed through skin. I just mentioned it. Your skin is no barrier for nanoparticles. It is just a gateway. It just enters without, it is just a free pass. It just enters there. Then it triggers inflammation and weakens the immune system. And it interferes with regulatory mechanisms of enzymes, proteins, and hormones. And as long as a life goes, these three are undisputedly the most important reasons why the metabolism of life functions the way it does. You have enzymes functioning in order, you have proteins for formation of life, and you have hormones for regulation of your activities, and all these three have been found to be impacted enough. Then environmental issues, it could accumulate in soil, water, and plants. And the new risk assessment methods are needed, because right now what we are doing is we are just seeing the soil and monitoring it over a period of impact, over a period of time, just testing that is nanoparticles still there, or is the problem still there for which we introduce the nanoparticles. But I guess as more we are studying, as more we are knowing this new friend of ours, as more we are understanding the behavior of nanoparticle, I guess it is high time that we all agree that new assessment methods of risk assessment, communication, and risk mitigation should be devised, developed, and communicated. Now, what are the potential risks of use of nanoparticles? So, the irony is we cannot even call it a risk right now, although in certain measurable parameters, in certain tangible outcomes, in certain areas like medicine and food, people have started notifying it, but we do not have enough studies to support the exact mechanism of the action. We do not know at what is the attachment site of nanoparticle when applied in field during a varied set of experiments. We do not know what happens when that site of attachment changes. We do not know how does it behave, what attracts a nanoparticle to that particular size. We do not know the risk parameter as of now. It has yet not been completely defined. The toxicity studies on different systems is slowly picking up, because for everything we need to now identify what could be the toxicity and at what scale. So gradually we are including it in all our researches, and also it is making a big awareness point. Even the reviewers, when you send a paper to any prestigious journal, the reviewer invariably would ask you, did you do the toxicity parameters? What were your key parameters you assessed the nanoparticles against? And then there is no mechanism for recovering of nanoparticle from the environment. Now, at this point, you'll be surprised that recovery mechanism. Suppose we have arsenic unleashed in the environment, in the soil. What mechanism we have to collect the entire arsenic from the soil and just stop from spreading it further? We do not. We do not have it. But arsenic would still not cross the blood-brain barrier. It would still not find DNA as its attaching site. Nanoparticle may do it. That is why this is a bigger weapon unleashed. That is why this is a bigger danger we should be careful about. And then half-life studies and the residual studies are not done. When we release a nanoparticle into the environment, we do not even know what would be the half-life at which it would be disintegrated. Because right now the scientists are feeling very surprised, to some extent guilty also, because what they thought that nanoparticle would remain nanoparticle in an ideal world until the task is completed, they are rudely shocked to see that it actually agglomerates and form different particles. It is not even operating at the nanoscale, and it is giving a very different impact. So uh, we don't even know what would be the half-life, and half-life of what. Even if we have to look at it, what do we look at it? What are we even trying to find? We just don't know right now. So, just to give a little more strict thought, is nanoparticle going the plastic way? Like, the fact is that 10 million tons of plastic is being dumped in our oceans annually, and that is equal to more than a garbage truckload every minute. Now, do you understand the magnitude of this? This is for something which is measurable. Plastic is measurable. We are more concerned about microplastics, and we have yet not got over with the microplastic menace. Nanoplastic is already knocking our door, is already buzzing enough. So nanoparticles, we will never get this volume like 10 truckloads or 50 truckloads because of the reasons I spoke just now. And 50% of all the plastic produced is a single use plastic. Nanoparticle are mostly single use only now. We just release it. We just release it in the soil. We just apply it as a coating. That is, one time we do it, we do not recover it back. So nanoparticle is mostly for a single use. Then less than 9% is plastic is recycled, nanoparticles we can't even recycle. Then 100% of the mussels which are tested, mussels are the food, the seafood. If you go to countries like Korea and Japan and Far East countries, Vietnam, mussels are one of the favorite foods of the people. They use for feast, and 100% of the samples tested have been found to be contaminated with microplastics. And humans eat 40 pounds of plastic in at least 1 year, and there'll be more plastic in ocean than our fish by 2050. This, please bear in mind, this is, I'm talking about a very tangible commodity, that is plastics. I have yet not got this data or even worked on this data for a nanoparticle, because I know I'll never get that. There is no way the technology exists. This gives a very interesting question to the future researchers, to the future technology developers, that can there be a monitoring mechanism which can be developed while we are developing nanoparticles, while we are developing nanotechnology more and more. So why do nanoparticles exhibit toxicity? What is so bad about them? The smaller size, then the surface charge, their higher reactivity, and then the generation of reactive oxygen species. This is something which triggers the mismanagement in most of the living systems, in most of the living cells. And now, when I say living cells, some of those who deal in chip engineering, who deal in electronic and electrical engineering, computers engineering, or machine engineering would say, living cells, you said, right? No way concerned with us. But as we are talking, this is not even a boundary. It has already emerged its area. We are applying all machine technology into healthcare. We are applying all these machine technology into efficient agricultural production. The boundaries are merging. The gray areas are becoming more and more bleak. It is all becoming integrated systems. So in very near future, there'll nothing be a core engineering and a life science operating in different silos. It all be operating together. So we just cannot make a system which is operating on some different planet. No, it will be on this earth, and some way or other it will be latching onto you also, your core theme also. So there has to be an integrated technology development and integrated risk assessment development, so that before we reach the point of no return, we have enough control in our hand. And please remember that no amount of regulation can be foolproof to ascertain that that the level of damage in a complex biological systems influenced by the number of physiological and environmental factors. And by the time the recovery mechanism is established and approved, we all know it would be too late. And sometimes we focus on only the target problem. But please remember, there is a whole big percentage of pie which is non targeted, and it gets impacted for no reason, for something which it did not ask for. So please also have a very important segment of non targeted organism or segments while you are working on technology. Now, having said so much about technology, if I ask what would be the technology, so I had asked this question so many times to my own self, and like I would very conveniently conclude it is not the best definition. In fact, it is not a definition, also, it is just the collection of some thoughts. You may improvise it, and we may come to a better definition. So, for me, technology is a tool for making the tasks simpler. And it should be so simple, it should be so indispensable and so reachable to the last mile that if you take it away, the function becomes, if not impossible, at least miserable. And what it could be, let's talk about it. And if the technology is not up to this scale, that means if it is not so simple, if it is not so indispensable, and if it is not so reachable, then everything else is a lab research. So, why do most of the technology and startup ideas fail? So, I had already talked about it, that they miss the critical point of intervention, which is going to cause the disruption. The disruption can be in the result, the disruption can be in the operation, the disruption can be in the function, it can be in the efficiency, it can be in the return over investment. It not necessarily be something which has to be a very breakthrough type of a research, but any disruption which makes it fruit bearing, any disruption which makes it better, which makes it safer. And when you miss that critical point of operation, whatever you are doing, you are just either optimizing, you are scaling up or scaling out, but you are not innovating. Because if your innovation, if your technology pushes the world into a gray zone, if it pushes the world into a darker zone, into a non recoverable zone, then it is not even a technology. Now, what is my I have a dream moment, like Martin Luther King. So I have a dream. And how do I see the future of technology? I see the future of technology at the level as basic as the water bottle or an incense stick. Now, this, some people might feel it is a very, very ridiculous example to give. What else it could be? For me, the technology should be accessible, small, easy to operate, user friendly, sustainable, degradable, and not overstaying its welcome. For me, that is a technology. I would be very happy if you also agree to this, but I would even be happier if you could add some value to it, revise it, modify it, and help me to bring to a better conclusion. So for me, the technology, the innovation, the disruption should be as simple as a water bottle or as an incense stick. You don't require a very basic person, a very last mile person who's situated at the tribal remote corner of some horn of Africa You don't need a rocket science for him to tell that this is how you burn an incense stick. And after the job is done, there is no trace of incense stick at all. That should be the technology. Not that, like now we are recovering plastic from everything what we are putting our hands on. That is not a technology. That is a regret. Now, how does platforms like IEEE connect, collate, and relate? IEEE gives a suitable interaction platform to researchers, fresh researching brains, and all at all generations. IEEE is a platform where everybody looks up to the stalwarts who are ready to mentor, ready to merge, and also they share their lessons and their way forwards. This is one platform I personally feel which is shy proof. The scientists, the stalwarts are not shying away from sharing their failures to the budding researchers, sharing their failure stories along with their success stories, and they help. And for young researchers, this platform helps to identify their mentors. It helps, and for the very senior researchers, it helps to identify the budding potential, the budding research idea, and to find the spark in the student, put him in the right perspective, and then work together. I can very safely say IEEE allows to fail and supports enough to restart with full confidence. So now how do I see the future of science? Now, being a woman and being a strong proponent of women empowerment in science, I would unbiasedly say that future of science is women. And I mean no offense. Future of science is definitely women. Why? Because we have organic networking skills. We do network all the time. It was crudely known as chatting. Then it refinedly known as sharing. Now it is known as networking. We know how to get things done just by being empathetic, just by accepting the failures, just by giving a room, giving a fresh perspective. We have a critical thinking. We also have a fairly good control over budgets. Believe it or not, the kitchen budgets were always run by women. The household budgets were run by women. The research budgets will definitely be run by women. And right now, need not to say more, our finance minister is a woman. Then, quick corrective approach, because women had always been traditionally and ethnically, women had been guilty or charged guilty of everything which has been falling from the sky. So now she has developed that mindset. All right, wrong has happened. Let us think through it. Let us make some correction. She has not taken it on her ego. And that is the evolution, I must say, to her scientific brain. That instead of taking it to her ego, that if I have said it, it is all correct and set in stone, that acceptance and okay, I might be wrong, let us redo it again. And that is the basic property a scientist should have. Then our basic nature of diversifying. 1 hour we are in the research laboratory, another hour we are in a meeting, third hour we are in a boardroom, and fourth hour we are in the kitchen dealing with groceries. So that diversifying helps us to disconnect. And if you go through the research problem, if you go through the biggest problem the world is passing through is the mental health, because people do not know how to disconnect, unwind. And women have been organically trained over generations for this trait. So I think this is very much our time now, and we claim this territory. We claim because of our passion, our curiosity to know new things, our adaptability, from very tiny girls to getting sent off to very unknown families, adapting for generations in that family, for new cultures and customs. Now you just take it, imagine it into a research methodology. Same thing, just the scale of operation has changed. The mindset has evolved. The space has been widened up. And we have realized that one hand of ours will always be for pulling up the next generation into research. So, unbiasedly, I say it strongly, the future of science is women. And not only me, the government also sees it the same way. There are several schemes which have been launched to bring back the women in the science force mainstream. There is a huge voice of considering the scientific age rather than the biological age for promotions and delegations of senior roles. And globally, women are coming up as a mutual support system for each other. And how do I support women? I just don't preach, I practice also. I give them a lot of opportunity as a PhD research, as postdoctoral research with me, irrespective of their family status. Then personal mentorship. With great pride and humility, I say that I am a global mentor to so many women science groups across all levels of education: tribal, school, college, coming back, breakthrough, at any level, industrial level, startup level. I have been mentoring a group of women always. And this is, I feel, a little contribution I make. I voice their constraints and concerns at the appropriate level. Thanks to my previous experience and connects at United Nations and at Commonwealth and at national and international agencies, I am heard to a certain extent. So I convey my point, hearing from these people, so that systems are made better for women. And reaching out to diverse group. For me, when a person comes to me for working, irrespective of her gender, irrespective of her family status, irrespective of her preference, he or she is just a person and a researcher in making. Nothing more than that. So I respect the diversity, I respect the space. And to do everything else, I constantly improvise myself to be a role model. I don't want to be a smaller role model. So I am constantly stepping up, I'm constantly improvising. So these are a few research papers from my laboratory, which, if you just go through, most of them have been written by women research scholars. And that is what my lab does: encourage women all the time for technological upliftment. These are the nanotechnology papers. They work very thoroughly in nanotechnology. And with this, I thank you for a patient hearing. I would be very happy to interact in case I am able to answer something or maybe help in some or the other way to you.
Thank you, ma'am, for sharing your thoughts. Now the platform is open for the question and answer section. We can see the chat box is full of questions. I'll read one by one. The first question is, what is the scope of funding in this field?
What is the scope of funding?
In this field,
What is the scope of funding in the field? I didn't understand
yeah.
that.
I think this field means nanotechnology or
Okay,
research
so
in the
what is the
field
scope
of
of funding in this field? Right. So in India, we have a national mission on nanotechnology, and apart from that, the respective areas where we trying to conduct the translational research, government is funding for it, industry is funding for it, and at United Nations also, like FAO and all. If you intend to do your work in nanotechnological applications, then through food or agriculture, then FAO and United Nations also fund. So, and even STDF fundings are also available. So depending upon what proposal you intend to present, so most of the time it will narrow down to the area of your operation. Then next question, shall I take? The next question is, what
yeah,
nanoparticle is suitable?
which nanoparticle is suitable for heavy metal ion detection in soil and water?
See, this is again a very diverse thing. What nanoparticle is suitable? Because right now we have yet not even concluded that what is the scale at which nanoparticle operates as nanoscale in a very dense system like soil. So, heavy metal detection, we have various tools and techniques available, but for detection of a nanoparticle as a heavy metal like a arsenic nanoparticle or something, for that the technology is yet to be developed. And again, I would say it would still depend upon the type of soil we are talking about.
Okay.
Then
How to start a research to carry toward industrial productive application?
how to start a research to carry towards industrial productive application. Uh, my personal experience says that do not work in isolation. Please have industry on board. Try and understand, is your research needed? Just don't work in like a free electron. Just don't work in a free field. Just see the end. That means the dispersal of your product, dispersal of your technology. So once you get it from industry, then you make a product for them. So it is like a customized research, you would say, or a target oriented research. And then you know that this is the area which the industry is demanding and this is what I should be producing. So then it becomes a very coherent research. Then I'm a BSc student from State Government College from Tamil Nadu. I want to do research in nanomaterials. Please guide me. So Bilawal Pathan, I would the presentation had my email address because this would require a little more talk, and I would suggest that if you can drop me an email, and for that matter, anybody can drop me an email on my email address. I would be very happy to speak one on one with you because I would like to know your personal interest, your subject area which you would like to take the research on, and also what is your eventual aim of taking up research in nanomaterials. So it would be nice if you could just drop me an email and I would be responding to you. Then thank you,
Riti is asking, is working in nanotechnology field beneficial in industry point of view? What
Yes,
is
it
the
is.
scope for that?
See, it is industry is an interface of taking research to the last mile. You cannot exclude industry whenever you're talking about research. So industry has it has a gateway. Industry is very much there. But the thing is, industrial norms should be very much in place because you can't blame industry at the end of the day if you yourself do not have norms to operate. So everything should, again I'm repeating it, everything should be working in coherence and in synchronization with each other, not in silos. And industry is an integral part of taking your work to the last mile. You develop a nano urea molecule in laboratory and industry takes it as a nano urea gunny bags. They upscale it, they scale it out, and then they do the translation of it. So it is very important to have industry on board. Please do not exclude it. And the next it says,
Ravi Yadav is asking, please guide how to search for good opportunities in foreign countries, job or research relevant to nanotechnology and material science.
yes. So I would say, Ravi, again, you please drop me an email. I am going to give you certain links. So those links will have enough information. So that should be helping you enough. So if you can kindly drop me an email, my email address is in the presentation. I would be giving the, in fact, I write here also so that it becomes, in case you have not noticed. Yeah, so you can just drop me an email over this and I'll be responding to you.
Geetesh Pandey is asking, I am working in developing sensors for soil technology analysis. How can I use these nanoparticles and further integrate it with electronics for a proper current or resistance change?
For a current or for a proper current or resistant change. Now see, if you have a nano coating, again see Gitesh, the time is less, and this, because I would like to share my experience with you while working on nano sensors, okay, to measure the soil moisture. So we had done this work previously and we realized that how efficient the system was and what were the limitations we faced. So if you can just drop me an email and then over a Google link, if I can discuss this with you. But in brief, I can just tell you that nano sensors are way better than the basic sensors, which moisture sensors, which we had been using, because nanoparticles were like we were able to do the real time sensing, and also there was we had reached the almost the precision level of the requirement of moisture. So soil moisture aspect, I can tell more about it. But if you want to know more about soil quality, that means macro and micronutrients in the soil, then increasing soil porosity, top carbon level. This is all what I can share my previous work with you, like either through slides or maybe we can have one-on-one interaction. Then next is, can you comment on cost of
Next,
manufacturing of nanomaterials and are they viable means to replace current existing bulk materials? Yes, nanomaterial cost depends upon first, where do you want to use it? Second, the scale at which you want to develop those nanomaterials. If you want to use it for just coating, Okay, coating would be requiring certain amount of nanoparticles, and if you want to make nanoparticles out of silver, so silver nanoparticles would, or gold nanoparticles for that matter, would be very expensive. They may be having extremely good efficiency when it comes to as a antimicrobial agents, but the cost would be a detrimental factor or a limiting factor. But at the same time, if you use a nanomaterial or nanoparticle from a biomass, let us say cow dung, so the cost would drastically reduce. But then that cow dung nanoparticle would not be used for electronic industry, it would be used for agricultural industry. So when we talk about cost associated with the manufacturing of it, you need to have the source and the sink very, very clearly defined. And nanoparticles are definitely the best, the viable, and the future technological means for replacing the existing bulk materials, because bulk materials not only difficult to produce but are very, very energy intensive. We need to reduce this energy intake, whereas nanoparticles consume less energy, and then the surface to volume ratio is fairly high, so the efficiency is also more in contrast to the bulk materials. If you still want to discuss more, Vidya Bhan, we can actually like my email address is there, please feel free to drop me an email. Then how researchers are addressing the.
Himadri Jyoti is asking how researchers addressing issues, toxicity, and environmental impact when developing nanotechnology-based products for agriculture.
Now this is the whole concern about, we do not have enough mechanisms. In fact, apart from me, I only know two or three people who talk about nanotoxicity. And since like my paper was the first paper in the country who highlighted the need of regulation of nanoparticles in agriculture, and when it was caught by DBT as an attention, they formed a committee, and I'm the member of that committee with stalwarts like Professor Alok Dhawan and all, who speak about nanotoxicity and toxicological research to a greater extent. So very, very few people talk about nanotoxicity in agriculture, in food production, and but now this trend is increasing. The policy is getting its shape. The first draft of nanotechnological use in pharma is already there. It is in place, like the full-fledged policy, and the agricultural policy, we are just giving the final inputs, and very soon it should be out for regulation. We are getting there, but the fact is awareness had been a little late. So you have very few researchers talking about me. If you want to still talk more about it, then again please drop me an email. This
Okay,
is.
she's again asking, what do you think about low number of women faculty in IITs, professors, and research domain as compared to men?
As compared to men. Okay, so I can't answer you about past, because in past women had a very specific inclination for non-engineering themes. This is something, a question when we say why medical colleges are mostly full of women and engineering colleges are so full of men. This is very much like that. But that was a general likeness of a subject. Women at certain times liked life sciences more, but now they are breaking ceiling. Then also the outreach of engineering colleges to all the districts and cities were not there, but medical colleges people always had a fancy and they could reach there. At least nursing colleges they could reach. So the availability of the technical education was definitely less to women, but now it is improvising, and now we have good number of women who are stepping up into the engineering education. Then IIT has, even all IITs, IICs have given enough platform to women as special drive in employment. We do not have reservations for women per se, but then we have a consideration. That means we give a special drive. Our previous director had given a special drive for women. Like, if you're capable, if you're well qualified, if you're interview go for a competing quality level, then you can be as on board as your male person, as your male colleague. So there is no discrimination, and that itself is good enough. Then for students, for women students, we have more seats encouraged. We have increased the number of seats, a percentage criteria, not in terms of qualification, but in terms of head count. So women are encouraged more. We have special hostel facilities, and it is being increased also. So women are now being increased in technical education, and I'm very sure it will be very soon. We'll have IIT professors, more women also. We really look forward to that day, Jyoti, and you could be one of those. I am not surprised if you could be one of those. So, could you elaborate which specific type of nanoparticles, if any, have the potential to enhance the soil quality? Jyoti, again, I would tell you, quality is a very subjective word. When you say quality, what is that which is missing, and you call it a non-quality thing? Is it the micronutrient? Is it the porosity? Is it the water holding capacity? Is it the resilience of the soil? Is it the nutritional level? It is the pest management. What is missing in that soil, which is making it a non-quality soil? Right, and if that is missing, like let us say, of all the things which I spoke right now, I speak microbial properties. The resistance to attack of pest should be a good quality of soil. So for that matter, silver nanoparticle has been proving its metal for so long, except for the fact that it is extremely toxic to non-target also. But for pest management, we are using silver nanoparticles, but now we are even switching over to green nanoparticles. So, what aspect of quality you want to address? Based on that, the corresponding nanoparticle is there. So, Brahmadatta says that after completion of PhD,
Ramadatta Mahapatra, yeah, he is asking after completion of PhD, we need some experience to join IIT as a professor. So, which experience is better, postdoc or industry?
I would say postdoc is better because it somehow keeps you focused not only in research conducting but also in lab management, in research operation, making you work very closely with your next target position, that is a faculty. So as a postdoc, you will know that what all are the tasks which a faculty needs to do, what all are the committees which are required before procuring, what all are the instruments which you probably be needing, what is the process of operating through GEM. So postdoc is kind of a hands-on training if you want to join IIT as a professor. But I am not saying that industry people are lesser of experienced people. We have wonderful faculty who had been industry colleagues beforehand, but then they learn on job, right? While postdoc, you get to learn kind of prior, you get to know the important questions before your exam. The major day you join as assistant professor, you know what you are dealing with. But if you come from industry, you learn on job, you learn after getting on board, but then you eventually learn. There is nothing which you cannot learn. So don't limit your options just based on these two. I would also say try for international agencies, try for volunteering organization, try for startups also. But make sure you deal with the last mile and see how the research gets impacted. If you happen to develop that vision, any step you take in your research career would definitely make impact in the large scale. So that is all what I have to say. And thank you so much for your kind comments. Please feel free to drop me an email. I would be very happy to respond and connect.
Okay. So, thank you, Dr. Kavya, for such an informative and engaging session. We are grateful for your time and effort you took to share your thoughts with the audience of IEEE NTC Student Branch Chapter, IIT Indore. Now, I would like to thank Dr. Kanika Singh, Chair of IEEE NTC Women in Nanotechnology, for their guidance. A special thanks to Professor Chaiban Mukherjee for their valuable guidance. Thank you, Dr. Pavan Kumar and Dr. Sanjay Kumar, for organizing this event. I would like to also thank all the volunteers for their effort. Lastly, I thank the audience for attending the event, Research with Charcha. So thank you so much, everyone.
Thank you, Shruti. Okay, then have a good day.
Thank you, ma'am.
Good day, ma'am.